We're going to start our graphing unit here. So we're starting with relations and functions. So determining what could even be graphed is kind of where this unit takes us. So just a little bit of a review. The XY plane is also called the Cartesian plane and is named after the mathematician René Descartes. So the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. All points can be labeled with, they meet at the origin. All points can be labeled with coordinates and expressed as ordered pairs where it's always x and y. We write them in brackets with a comma separating them. The XY plane is divided into 4 quadrants called 1, 2, 3, and 4. Always label the axes and mark the scale. Oopsie. Okay, so in our graph here, we'll mark our 1, 2, 3, 4 planes. So you can see that we've highlighted that this is our x and this is our y. X is the horizontal, y is the vertical. Quadrant 1 is here, 2, 3, and 4. All right, so use this plane to complete the questions. So state the coordinates of each point. If you look here, we're looking at A. And A, we list the x value first. So it is at x equals 2. And y, how far up is it along our y-axis? Well, it's between 6 and 8, which is 7. B is on the other quadrant. It's in quadrant 2, where we list our x value, which is -4, and our y value is +6. So continuing in this fashion, you should get the D is -3, -3, E is 0, 2, again, because in the x-axis, it is only straight up. It's at 0 for x. And F is 7, -5. Graphing the points below. So T is at x equals 6, y equals 4. So that we should label as T. V is at +5, -1. W is at -2, +3. X is at -4, -5. So that'll take us down here. Y is at 0, +3. And Z is at -4 and 0. So its height is 0. Make sure you're comfortable writing the coordinates for these points. All right, so that's our review. New stuff here starts now. So a set is a collection of distinct objects. An element of a set is one object in that set. And a relation associates the elements of one set with the elements of another set. And when we write the coordinates of a set, we write them in brace brackets. So that doesn't make a lot of sense until we get into our examples here. So order is important in every coordinate point, is something to note. Sorry, it should have been on my previous page. All right, this is our first example. Animals can be associated with the classes they are in. Describe this relation in words. So we see here that we are given a list of animals and a list of classes that they belong to. So the relation that's being shown, so how we go from animal to class, is that it belongs to the class. Okay, so the relation shows class, it shows belongs to the class. So just how we would relate the two. Okay, so it's between a set of animals and a set of classes. All right, represent this relation as a set of ordered pairs and as an arrow diagram. So ordered pairs, what we'll start with. We always write them in the loopy bracket, and we'll write the first one first and the second set second. It's really important that we work in that order in our table. All right, so ant belongs to insecta. Okay, so separating them with a comma, just like an XY pair, but they aren't X and Y yet. And separate all of them with commas in between coordinates. And end with another curly bracket. All right, if we want to represent this with an arrow diagram, what we're going to do is we're going to list the distinct elements of each set. So if there's something that's repeated, we only write it once. So in our first set, we have ant, eagle, snake, turtle, and whale. And we just put them in their own circle. And I label it. I like to know what the class, like what this was describing. The other set, insecta, aves, reptilia, and mammals. All right, so because reptiles were repeated twice, we only write them once, and these are the class. Now, to show the relation, we describe which match to each pair with an arrow. So because snake and turtle were both part of reptilia, we draw an arrow to reptilia from each, and whales from mammalia. And if you wanted to, you could write the relation here, and it was belongs to the class. Okay, so that's an arrow diagram and a list of pairs. We can also use a graph. So if we're looking at the graph here, different towns in British Columbia can be associated with the average time in hours that it takes to drive to Vancouver. Consider the relation represented by this graph. So the graph describes the average travel time to Vancouver. That's the relation between the values here, aka the towns, and the values here, the time. So consider the relation and represent it as a table. All right, so in a table, we always list our X values first. And because this is the X portion of our graph, we're going to list the names of the places first. So Horseshoe Bay, Lillooet, Pemberton, Squamish, and Whistler. And the time in hours is, so for Horseshoe Bay, it looks like 0.75 hours. Lillooet is 4.5 hours. Pemberton is 2.75 hours, Squamish is 1.5, and Whistler is 2.5. So again, we're always putting our X value first in our table. as an arrow diagram, we list our x values first. Okay, so again, the left side of our table first. So Horseshoe Bay, Lillooet, Pemberton, Squamish, and Whistler. And these were the towns. I should have labeled that up here. And the time. Now you can write these in any order you want. You could write them in the exact same order so your arrows just go straight across. That's fine. Or you can put them in numerical order. Again, that's all good. Okay, and then our relationship is just each one. There were no overlaps in this case. All right. So in the diagram here, we have English words and then relating them by the number of letters they have to a set of natural numbers. Okay, so an English word and how many numbers of letters it has. So the relationship shows the association has this number of letters from a set of English words, whoopsie, to a set of natural numbers. So list two ordered pairs that belong to this relation. You could write any two words. I chose number, which has 6, and mathematics, which has 11. Okay, finish that, and then swirly bracket on the outside. So what are the advantages and disadvantages of the different ways you can represent a relation? There's a bunch of different things. So a relation is very explicit in some instances versus kind of implied in others. So you saw that we had to read the question in example 1 to get the information about animals to class, versus the diagram here with English words and natural numbers. It's very clear. So just how you read it. It's easier to read pairs in ordered pairs or tables. It requires more interpretation for graphs or our arrow diagrams, I find. There's so many different things you can say here. Why is the order of elements in an ordered pair important? Give an example. So it describes the set they belong to. If you had ordered pairs that were math, which is 4, and then from the previous set, and then you said cat, which is 3, if I went to put those in a table, I would have math and 3 in one side and 4 and cat in the other side. I can't describe the categories or the sets that these are. So it's important to note because it describes the set they belong to. Describe the relation in words here. For the exit task, represented as an ordered pair and represented as an arrow diagram. Pause it and try this now. The relation in words is a set of sports is played with, is the relationship, is played with a set of equipment. The relation as an ordered pair, you should have badminton racket, hockey, comma puck, tennis, comma ball, soccer, comma ball. And then the arrow diagram should have sports in one and equipment in the other, where ball is only listed once.